Here I am back on the North Beach at the Portobello Marine Lab, New Zealand Marine Studies Centre, University of Otago, right on the edge of Otago Harbour. And here we have Alice, who you've met before in topic 4 of investigations about turbidity, and Gabby, who you would have met in topic 3 about light. So over to you, Gabby and Alice.
Kia ora. So we're going to be the faces of this level 2 topic about benthos and sediment.
Benthos? Did you say benthos? What's that?
I sure did. Well, actually, you're standing on it right now. So the benthos, it comes from the Greek word which means deep. And so
We're not very deep right now.
no, so on the surface we're kind of looking at substrate. But even over here, this rocky reef, the really stable cover, all these big boulders down to the cobble, and even this fine sand grit, gritty-like stuff, it's all benthos. So here on the rocky reef, if you turn over some of the rocks, you can start to see that there's a lot of life digging deep into this benthos here. And we can go from the gritty sand down to much finer different substrates such as clay and silt and mud. Well, they're going to break down over time, over really long periods of time, and they'll eventually come into the sand, and then over much longer time they'll break down even further into this sediment.
Oh, okay, I get it. So there's animals that live here, like this little shell. This is not a cockle.
It's a type of clam.
That's a type
But
of
yeah,
clam.
other things like worms too, they love sandy and muddy shores, and we'll go explore some of those later on.
Oh, cool. So benthos is all of this area here. When the tide comes in, it will cover this. But what about everything back here?
So everything that is the seafloor is benthos. So it's not just the intertidal, it's subtidal, so below the low tide mark, out all the way into the harbour and past the coastline. Every part of the seafloor is actually benthos.
Oh, that's really cool. So you can go anywhere along the coastlines or the harbours and estuaries in New Zealand and find them.
Yep, so walking along the beach is benthos. If you go diving or snorkeling, and you might, brush your hand on the bottom there, you're touching the benthos. Let me take you to another intertidal. We'll go visit some soft shore benthos.
Great.
So here we are at Lake Bay, which is a soft shore or muddy shore environment of the inner harbour of the Otago Harbour, and we're just round the corner from the New Zealand Marine Studies Centre, which is over there. So, as most of you may know, South Gabby, that the Earth is made up primarily of ocean, and of that ocean, the most common surface or benthos is the soft and muddy kind of shore environment. So as you can see, it's really, if you touch it, it's that really fine kind of loopy material there, so you can feel a little bit of grittiness in it, but not too much.
Alice, does anything really live here? All I see is what looks like just a bunch of mud, and I guess there's some seabirds over there, but I don't know what they're doing.
Well, the seabirds over there are actually feeding on some plankton, which we've already covered in another topic.
Oh, that's right, Tamlin was talking about that.
Yeah, and so some of that plankton will actually be the juvenile forms of some things that are living in the sandy and muddy shore.
Wait, so they're living in this mud underneath here?
Yeah, so it doesn't look like there's a lot of life here, but actually there's lots of things, but they're all just below the surface. So that's why we're going to use one of these cores so we can figure out what kind of things are living here.
This just looks like a plastic PVC pipe.
Well, it is, but it's a simple tool that we can use to find out more about our environment, such as the things that are living in there, as well as other things such as how much oxygen is in it.
That's cool, so I can figure out what it is and make it.
Yeah, definitely. It's super easy to use. So, pop it into the ground like that, and I want you to stand on it and try and wiggle it down. Okay. So yeah, you can use me for balance. Yeah, keep going.
How far down does it go?
Well, it should go down all the way, but I mean it's going to vary depending on where you are. Every kind of estuary is a little bit different. just collected. So we're going to measure from where it goes from brown to black, because that's where the change of oxygen is.
Okay.
So if I move this down, do you want to take a reading of?
Yeah, so I think right about there it changes. So it looks like about 50 millimeters.
Cool, awesome. So now what we're going to do is we're going to use the water that's coming in, and we're going to sieve out all the sand and see what living things we can find. I will go a bit deeper. Yeah. So again, really easy equipment, you know, a ruler, a sieve you can just get from the warehouse or something like that. So you can go out and do this yourselves in your local estuary or soft shore.
Wow, there's really a lot of stuff in there.
Yeah, unfortunately a lot of it looks empty, so it's not alive, but we do have something living in there, maybe. So this is called a wedge clam. So you can sometimes see their feeding marks on the shore. They often look like a bit of a bird's footprint, but they're actually the marks of a clam, which is pretty cool. So that looks like a very juvenile cockle. So some kaimoana, so that can be a sign of a, you know, healthy habitat, because obviously it's a habitat for small things that are living in here. And remember, what we're standing on right now, this kind of sandy, muddy stuff, is what most of the ocean floor will look like. So wherever you go, you will find a similar environment to this, which is pretty cool.
That is really cool. I've spent a lot of time on the rocky seashores kind of outside on the coastline there, but not as much time here in the harbor. And I have heard that this harbor used to be...
So it originally was a freshwater valley and housed glaciers, and in these glaciers there's a lot of water that was held up or kept there in the form of ice. But when the ice age things changed and the glaciers melted, more water went out, and that means the sea levels rose. So even the Otago coastline that you know, it used to be a lot further away than it is now, because the sea
really
levels
cool.
rose. Yeah.
And so the Benthos can tell us all of that, kind of show us things from the past.
Yeah, so it's kind of like this record through time, which is really cool, so we can find out more information just by looking deeper of what's below us right now. And with these glaciers too, it's quite interesting that along with releasing all this water, they released a lot of sediment too. But we're going to talk about that more in our next video.
Okay, sounds good.